name is Yang. Today I'm going to talk about electroreception in the Guiana dolphin, Sotalia guianensis. And first, I'll show you today's main character, Guiana dolphin. Guiana dolphin is frequently described as looking like the bottlenose dolphin, but it's typically smaller. It's 2.1 meters and 80 kilograms. And its habitats are distributed in estuary, cover, and coastal shallow water, so people can find them in both seawater and freshwater. Let's start from introduction. We know the various aquatic environments of the world are not uniform, and the operating range of visual system can be quite reduced by low light level or turbidity. So mechanical senses like hearing, echolocation, and the perception of the water movement become more important. Electroreception, which we can regard as a kind of mechanical senses, and it can be both active and passive. In active electroreception, the animal generates the electric field and sends the change of it, like genotophones. In passive electroreception, the animal sends the electric field of their prey, like catfish, cuttlefish, and platypus. Now I'm going to talk about seals and toothed whales. Seals lack a vibrissal system, and they use their vibrissal to detect and track their prey. And there's a lot of nerve cell and blood vessel under their vibrissal. We call it FACS. Follicle sinus complexes. How about toothed whale? Toothed whale lose their vibrissal hair after they're born. And so we can see the empty crypts over there, and we call it vibrissal crypts. So why they lose their vibrissal hair? And scientists infer that it may threaten their vibrissal system. And these vibrissal crypts are often described as vestigial structures. That means they are useless now, like our wisdom tooth and body hair. However, thermographic studies of vibrissal crypts in an adult Guiana dolphin suggest that they are functional sensory units, and similar to the FACS in the seals, spots of intense thermal radiation were found to be associated with each single vibrissal crypt. So to determine whether the vibrissal crypts are functional sensory units or they're just vestigial structures, we investigated them histologically. Based on the morphological results and the feeding of ecology of the Guiana dolphin, we developed the hypothesis that vibrissal crypts function as electroreceptors, and we'll test it later. Histology. This process is a little complicated, so I try to explain it in easy way. At first, the tissue samples were stored in 4% paraformaldehyde, and then the samples were sliced and were sectioned into cross, set digital, and transfer 7 micrometer slice. And to observe it, we send the sections with standard Mason-Gardner trichome staining technique, and then finally we examine the section with light microscope. And look at this picture. This is the experimental setup for psychophysical experiment on the Guiana dolphin. We train the dolphin to station itself in the device by placing its head in a hook and touching a small target of with its type of the mouth. And so this electrode were located exactly above the vibrissal crypts. And the dolphin were also trained to stay for at least 12 seconds if there's no stimulus, and to leave if there's a stimulus was presented. Tests were conducted double-blind by one trainer and one experimenter. Following a random order, the experimenter did or did not apply the stimulus, and after the trainer indicate the response of the dolphin, the experimenter informed him whether he applied the stimulus or not. And if his decision is correct, the trainer then reward the dolphin food. And we use a combination of the staircase method and the method of constant stimuli to determine the dolphin sensory threshold. Each of 6 stimulus strengths, 31 trials were performed and 186 trials totally. For control, the experiment was repeated with the vibrissal crypts covered by a plastic shell. 40 trials were performed in a stimulus strength above threshold. So let's see what we found. The vibrissal crypts consists of an ampulla-shaped invagination of the dermal integument, and it lack most of the characteristic morphological features of FSCS, like our hair shaft or hair capilla. So we justify the use of the term vibrissal crypt instead of FSCS. And we can see this expanded lumen was filled with keratinous fibers and corneocytes. And here, this. And the crypts were surrounded by the capillary network that appear to respond for the increased temperature seen in the previous thermograms. Here. The dolphin sensory threshold was determined at 4.6 microvolts. In test and in the control test, the dolphin didn't react to the stimuli, so we conclude that the dolphin's responses were due to electroreception. And this picture is the experimental result. We can see here is the electric field strength, and here is the percentage of the correct choice. And we can see 6 black circle and 6 white circle. The black circle means hit rate, and white circle means false alarm. For example, if the dolphin leaves the station correctly in response to the stimuli, we mark it black. And if the dolphin leaves the station mistakenly when there's no stimuli was present, we mark it white. And at 50% of percentage of the hit rate, the dolphin sensory threshold was determined at 4.6 microvolts. Discussion and conclusion. based on the psychophysical experiment, we conclude that during evolution, the vibrissal system has functionally transformed from mechanoreception system into electroreceptive system. And the histological investigation demonstrates that in addition to their simple structures, the vibrissal system has a dense innervation and blood supply. And it also supports our hypothesis that they are functional systems, they are functional structures. In both of monothrene and vibrissal crypts, we found intraepithelial nerve ending, and this feature is not known in any FSC-derived structures other than vibrissal crypts, but it is believed to be the basis of electroreception in the platypus and the echidna. Thanks, guys.
Okay, so 11 minutes and 1 second. Sky. Jesse. Rich. Sally. Sky.
Can you go back to the result figure? Yeah, this one. I'm not very sure the vertical axis mean. Yeah.
It means the percentage of correct choice. Correct choice means the dolphin leave the station when it's a stimuli, and not leave the station when there's no stimuli, means correct choice. So this is the percentage of correct choice.
I think that didn't fully answer her question. Next,
Oh.
Jessie.
Can I explain? Can I ask?
Okay. Rich.
Can you explain more about double-blind test?
Double-blind test. Okay. Double-blind test means the experimenter was invisible to the trainer nor to the dolphin. That means double-blind test.
Okay. Sally.
So can you explain SSCS again?
Okay. SCS in the paper is too complicated, so I explain it in an easy way. It's just like the under this vibrissal, there's a lot of nerve cells and blood vessels. So we call it follicle sinus complexes.
Okay. Jessie.
You think why this paper experiment target is this kind of dolphin is not other dolphins?
Guiana dolphin. I don't know, but it doesn't mention in these papers.
Okay.
Go on to your question, Annie. Sorry. And you also want? Okay, so first and then Sam.
Sorry, I want to ask, we all know that dolphins will use ecological to hunt, so is this dolphin only use electric field or both?
Only You say only use.
Only use electrical field, or he also will use ecological Zhuhang.
Use ecological? What do you mean by use?
Use echolocation.
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 I think, in this paper, Guiana dolphin hunt with not only with their biosonar system, but also use their vibrissal crypts to detect the stimuli, the electric stimuli. And I have no idea what you want to know.
Okay, stop here. Next, Sam.
I think my question is similar. I think I want to know that the Guiana dolphin will use this system to prey or not.
Of course, yes.
But in this experiment, doesn't show us
Okay.
the result.
Here, electroreception. The vibrissal crypt in Guiana dolphin is such like this. I think it's more like this one. Since the electric field generated by their prey, so they detect their prey with this.
Okay, stop here. I think overall his slides, most of the slides are relatively easy to follow because his text was not too long, and especially for the introduction part, it's easy to follow. But I think the discussion needs improvement. So you see these are actually a bit boring, and I think before the discussion part, the slides are fine, and especially the former slide, the slides at the beginning, they are quite nice with like this one. It has an informative header, short sentence, bullets, and often he also highlight the keywords. So these are easy to follow. And however, I think a major weakness of this paper of his presentation is because in this paper it has many anatomic terms, 解剖学的词汇, and these terms are actually difficult to. I think at the end you do not remember the terms like vibrissal, crypts. Okay, what's that? You still don't know how to read it without looking at the terms, which means the terms are difficult to remember even after you read it several times in the presentation. So, and this is especially obvious when he presents the histological results, which is this one. Okay, like this one, you can see there are many terms like ampulla shape, imagination, epidermal, integument. Wow, what's that? I don't really know what he's talking about. Even I checked the paper yesterday. So if I were him, what I would do is, you see these abbreviations? These abbreviations actually very often refer to some of the terms here. So if I were him, I would directly print these keywords directly on this image. Instead of just saying these words, they have no meaning to the audience. This is important because actually here, this AR means actually artery, blood, vein, okay? This is important because then later on in your discussion, you talk about where is the blood things? Okay, you talk about this tissue seems to have, seems to have innervation. Okay, it has nerve system and it has blood supply. And this, where's the data? The data is in the histology images. But because you explained it quickly and without explaining the detail, your discussion is disconnected from your data. Okay, so this needs improvement. And again, there was a student who asked what's the x-axis. Actually, this axis has two meanings. It also means hit, and also the black one, and also the false alarm, the open dots. But you didn't explain the axis well. I mean the axis, not the symbol. You explain the symbol, but not the axis. So when presenting a figure, you always start by saying the x-axis is what, and the y-axis is what. And then, if I were you, I would directly maybe write hit rate directly next to the line here, and false alarm next to the line here. So that the audience, it's easier to follow for them. And he put the concluding sentence next to the figure, which is good. But I would say, if I were you, I would not have a section like this. I will put this. Well, I will probably keep this one. It's a little bit like a conclusion for the whole talk. But for example here, I will put it next to the histology slides, because that's actually what the histology results show. And for this one, I think this is also related to histology. This intraepithelia thing is in the image, but you did not explain. So in general, in your discussion or conclusion slide, you should not show any new terms that you did not discuss or mention in your results. Like these new terms, you didn't talk about it, or it was too quick. And then there was a pronunciation problem, like unit, and overall, I think many of your image needs keywords printed directly next to the image. Okay, not just saying it. You print keywords next to it. And then I will also suggest that for the ease or comfort of the audience, for your key terms, like this super difficult, I still don't remember it. You see how difficult it is. This something, okay. Vibrissal crypts, if I were you, I would probably say something like a hole on the beak, or like a hole. These are holes, right? These are holes for the mouse hair, right? Mouth hair, like a mouth hair for your dog. Use easier terms, then they remember what you are talking about. Okay, thank you.